In this video, we're going to do an introduction to access lists. Now, this isn't going to be a fully comprehensive overview of what access lists are or could be, but just an introduction to give an idea of what they are and how they work. Now, access lists, if you're not familiar, are basically rules that are used by firewalls or other network devices in order to approve or deny access to devices. And as the name says, well, it is a list of rules to provide access. So let's look at a parallel you might see is a shopping list. So for instance, as a child, I remember going with my parents down to the grocery store, and we'd be going up and down the aisles, and obviously as a young child going to the store, I start seeing some things that I want. My parents are putting stuff in the cart. Why can't I? So I started saying, hey, can we put this in here? Can we put some chocolate in the cart? And my parents would say, it's not on the shopping list. It's not on the list. We can't add it in. Or, we keep going up and down the aisles and suddenly I see ice cream and I say, can we have some ice cream? They say, it's not on the shopping list. And so I quickly realized as a young and enterprising child that if it's not on the list, we don't get it. So even though there's certain items on here, if I want something else, I need to add it to the list. Down at the very bottom, there was a deny. If it's not on the list, we don't get it. So I came along one day right before we go shopping, and I found the shopping list, and I added in my own item. And I said, I want ice cream. And then we went to the store, and my parents were walking up and down the aisles. I said, oh, wait, there's something on the list. There's ice cream. And I didn't quite understand. It was on the list, right? That's the rules. But they said, no, not on the list anymore. So that was not so fun for me as a child, but it is a great example of an access list because it lists what is allowed, what is permitted. But at the very end, there was something else, which was an implicit deny. If it's not on the list, it's not allowed. So let's take a look at what an actual access list would be. And this is a very, very simple access list. This is not an access list you would see in real life. This is way too simplified. But we have a basic network here. We have a couple of different networks right there. And then here on our router, this is where the access list is. The ACL is put up. ACL, Access Control List. And then down here is the rules, down at the bottom. These are our rules. This is what's allowed, and this is what's denied. And you can see there's 3 different rules, and they're pretty much, we start off with a permit or deny. Are we going to allow this, or are we not going to allow it? So back to the shopping cart example, milk is allowed, ice cream is denied. So maybe along with the milk, they said no ice cream. So you can have both a permit and a deny in the same list. All right. So here we have both a permit and a deny, and we start off and we see, there's a deny specifically for 192.168.242.1/32. Now, I won't go too far into subnetting at this point, but the /32 means one specific host. That means one specific host with the .1 IP address. So let's see, 192.168.242, that's this network right here. So if this guy was the .1 address and was trying to send information up to the router, it would hit this line on the access list and would get denied. And that's how it works. It looks through the access list and says, does this match what's on my list? If so, I'm going to do what's in either the permit or the deny column. So that was 192.168.242.1. The next line we see a permit, 192.168.242.0/24. /24 means the entire network, which is basically going to be everybody except the .1. So if this PC6 is, say, .12, so 192.168.242.12, and he sends traffic up, what's going to happen is this access list starts from the top down, and it starts looking and it says, does it match this first line? And it's the wrong IP address, so it doesn't match that line. It's then going to say, does it match this line? And it is going to match that line because .12 is part of the /24 that's identified here. Since it matches, it's going to be permitted and the traffic will go through. Just that simple. So a couple of things we have to remember about access lists is, first off, is that it goes from the top down. Just like when you read a piece of paper or a newspaper article or something online, an article online, you start reading at the top of the page and then you work your way down to the bottom. So it reads from top down, top down. And then the second item to remember is that the first rule to match, first match, wins. And that's what we'll see here in this next access list or access rule. We have a deny for the 242.250/32. Again, /32 is one specific host. So if this PC6 is actually our .250 address, so 192.168.242.250, and he sends traffic up to the router, it goes from the top down. It starts looking off, is it match this deny rule? And it doesn't, because it's not the .1 address. It then says, does it match this permit rule? And it does, because it is part of this network segment here that's defined as an available source. Since it matches that one, the very first match wins. So since it matched, it never even gets to this guy. It never gets to the third rule there, and therefore that third rule is never applied. The .250 traffic that we may have wanted to stop is still allowed through. So in the order of the rules right here, that third rule will never actually be successfully reviewed. In fact, it could actually be deleted out of this rule. It's completely benign. It does nothing at all. If I wanted to make that rule take effect, what I would have to do is I would have to come in here. I would have to grab that rule and then move him right up here above that permit statement, because the permit was allowing all the traffic through before we block it off. Think of this as like when you're a kid in elementary school. Now, I don't know about you, but I got into trouble quite a bit in elementary school. And so the teacher would want to hold me back during break, during recess. And what she would say is, oftentimes she would say, everybody except for Ed can go to recess. So she would have to call out the specific people, so unspecific person, before she called out the general group. And so by doing that, they're able to specify this one person, no, don't go anywhere, but then everybody else can. Otherwise, if you call out the group and then you call out the specific person, well, I don't know what it was like in your elementary school, but in my elementary school, as soon as recess is called, everybody's gone. There is no way you can say anything beyond just have fun. Yeah. All right, so this is a simple access list, and this is basically just looks at permit, deny, and then who is sending the traffic. We're not worried about where it's going to. We're not worried about the interface or the directions or anything like that. This is just the very simple, who's sending me traffic and do I want to accept it or not? Access lists can get more complicated than this. Oh, I guess I forgot one. I forgot one last step, which was the prior slide, which I made an entire slide so that we wouldn't forget it. at the end of every list is a deny. So if these are my access lists, and don't take this for granted exactly the way I'm saying it, but if these are my access lists, then these are the only networks that are in my access lists. Therefore, in theory, this isn't exactly how it works. If this network over here tries to send traffic, there is an implicit deny at the very end, which would stop all of that. It's not written, but it's implicitly denied at the very end. Same thing with the servers. That would implicitly been denied. Now, it's not entirely that case because access lists don't actually work that way. They are a little bit more specific than that, which we'll get into in the next step, but there is still an implicit deny. So if any traffic that was not defined in this access list comes in, it will be blocked by default. Very important thing to mention there because everybody, myself included, forgets it. All right, so the access list can be expanded and be a little bit more intelligent. For instance, here we've taken the access list that we had right there, and we add in the interface. So we can be a little bit more specific. So let's say that this guy on the right-hand side is interface gigabit 0. Above that is gigabit 1, and then this is gigabit 2. So now we're able to be a little bit more specific and say these rules, these denies and permits only apply to this interface. That's why I was saying in that last step with the implicit deny, it didn't quite fit the way I described it because you actually apply these rules to the interface. So since I apply that rule to the interface, I may actually see traffic from 192.168.242.1 from possibly this address or this network. And that may come in to my router. Now, because this is coming in on gigabit 0 instead of gigabit 2, what's going to happen is the firewall or the access list is going to be ignored. It's not going to do anything specific to that traffic. It's going to say, hey, this deny that I have right here is only for that IP address on this interface. That's coming in off of G0. My access list does not apply. Now, I know you've got some IP subnetting or some IP experience, and you're saying, how could I have that traffic coming in on that interface when that is over there? And it is possible. Both from properly designed and improperly designed networks, but it is possible. But so the access lists can be expanded beyond what we originally saw with just permit, deny, and then the source traffic, but also with the interface. Now, the important thing to learn about this is most network devices where you have access lists, not all, but most network devices when you have access lists, here we apply the access list to the interface G2. So again, if this is G2, then that means it's supposed to be a G. If this is G2, then again, there's an implicit deny at the very end. And so all traffic on G2 is being monitored against this access list. And anything that's not permitted explicitly in this access list is denied. So anything coming in or out of G2 in this scenario is being denied from this interface. However, because that's only G2, we still have G0 and G1 over here with no access lists. Therefore, there is no restrictions. No restrictions on those interfaces, on either of those interfaces, because we don't have access lists. This implicit deny only exists on the interface once we put the access list there. If we remove the access list, the entire implicit deny goes away. All traffic is permitted. At that point, this guy is just a router, and a router's job is to send traffic from one place to another. So we can be more specific by specifying the interface. And once we do that, then that interface essentially is locked down. We're restricting who can be running on that. All right, so we can also get a little bit more specific. We started off by just talking about the source of the traffic. We can also get more specific by talking about the direction of the traffic. In this case, the direction is either in or out. And first off, what exactly is in or out? How do we define in traffic or out traffic? And that's, we kind of have to think of things from the network device's point of view, or this router's point of view. Let's look at a little bit more simplified network. So here we have a router, and we have two different networks. On the left-hand side, we have 192.168.50.0. On the right, 10.193.76.129. Should be 0. That's fine. But so we have these two different networks, and so in versus out all comes from this guy's point of view. So what do I mean by that? Well, let's say we have traffic. Let's say we have a host over here on the 192.168.58.0 network, and he wants to access a server over here. So what happens is the traffic comes this way, right? So he goes from his network into G0 and then out of G1. So it's in from G0 and then out from G1. From the router's point of view, traffic is coming in from the left-hand side of my screen, and it's going out on the right-hand side of my screen. And so that's the router's point of view. Traffic comes in from one side, and then it goes out on the other. Now, when the server responds to its traffic, what happens is it goes the other way. In this case, the traffic is coming in from G1, and then it's going back out of G0. So it's all the point of view of this communication was started from the desktop on the left-hand side and goes to the server on the right-hand side, and then the server responded by going from the right-hand side to the left-hand side. So it's all from the router's point of view. Doesn't matter if this is G0, G1, or G52. It's all comes from the point of view of the router's from the traffic. So if we look back at our direction example here, again, if this guy down here is G2, as we're saying right here, the direction of traffic means traffic going that way has the access list applied. And just like before, when we only applied the access list to one interface, now we're applying the access list to the interface in one direction. Since this is all in, all outbound traffic is free to go. It doesn't matter what the traffic is, all outbound traffic is free in this scenario. Okay, so we can then look at our rules here. And we've got, let's see, we start off again with our deny from 192.168.242.1. Again, if we have a host over here, .1, who's trying to send traffic from the router's point of view, that is coming into the router and it is being denied. All right, piece of cake. So what the router does is it actually starts looking at it and says, oh, which interface is this traffic coming in? That's G2. Which direction is it? It's inbound. What's the source IP address? Oh, that's the .1. So I'm therefore going to deny the traffic. And that's kind of how it works. It kind of, it looks at the interface, then looks at the direction, then the specifics of the traffic. So that was .1. Let's say instead we have .12. 192.168.242.12. Traffic comes up to the router and it says, okay, which interface is that? Well, that's G2. So I'm going to start looking at the G2 interface access lists. Which direction is it? Well, it's from the router's point of view. It is coming into the router, so it is inbound. So I'm going to look at this inbound G2 access list. And then it says, okay, is this 192.168.242.32? I'm sorry, .1/32. And it says, no, that's not the address it's coming from. Remember, we go from top down. Since that's not the address that it's coming from, it says, okay, let's go to the next line. Again, G2 inbound, is this 192.168.242.0/24? And it says, yes. Yes, it matches that rule, and therefore I am going to permit this traffic. Now, any other traffic, let's say from 172.16.14, comes along and it goes this way. What's going to happen is, first off, the router is going to say, well, that's not G2. But then, and from here, it is inbound, but over here on G2, it's outbound. All my access lists for G2 are inbound, not outbound. So it does matter. You can be a lot more specific on, do I want to block inbound traffic or outbound traffic? All right, let's get a little bit more specific. Sorry, no. Actually, that's about as far as we're going to go. These access lists can get a whole lot more complicated. Right now, we're just looking at the source, the source, the interface, and the direction. We can get a whole lot more specific by talking about the destinations. So not only who is sending me traffic, but where is it going to? What ports are being used? Both what's the source port as well as the destination port. We can do things such as zones. So we could start defining zones and having security zones. So this security zone can talk to that security zone, or that security zone can only send this type of traffic to security zones. We can start throwing in way more crazy things such as, is the connection already established? If you've already established a connection from one person to another, then I don't necessarily need to reevaluate the rules. And so what I could actually do is put up here at the very first line here, an established rule, and allow that to go through without having to reevaluate it. In theory, I've already evaluated it once. But then we can get even crazier, such as what user is there on that system? What OS is running? What antivirus are you running on your computer? We can get a whole lot more specific, but the idea is that the access lists all follow this same kind of general rule of creating a list. It starts from the top down, and then at the very bottom, there is an implicit deny. All right, so test time. Let's see if you've paid attention. Go ahead and look at this example and pause the video. Basically, we have some rules down on the lower right-hand corner, and then we have some traffic on the left-hand side. The traffic specifies the source, which interface it's being seen on, and then what direction it's going. So go ahead and look through these various rules and the traffic, and identify which traffic is being blocked. Go ahead and pause the video, figure it out, and we'll talk about it here in just a second. All right, so hopefully you've took a chance to pause the video and look at that, and let's take a look through our traffic. So we could start walking through here. See 172.16.14.52. That's coming in on interface G1. Our rules do not have anything for G1, therefore that traffic is not being blocked. That is being allowed. All right. Next one, 10.75.98.6 on interface G2, direction inbound. Well, let's look through our rules. G2, our rules are on G2 and they are inbound. So this access list does apply to it. We start from the top down on our access list. So we go this way. We look at the first rule, first source 192.168.242.1. That is not the source IP. Therefore, we do not apply rule number 1. Rule number 2, 192.168.242.0/24. That is not what's in our list there, so that does not apply. Third one, we have a deny for 192.168.242.250/32. That one is not in our list, therefore it is not applied. But at the very end, we do have an implicit deny. Therefore, this traffic is denied due to this implicit deny rule down at the very end. So that second source traffic is being blocked. Sucks. We didn't expect that traffic, but we're blocking it anyways. All right, so the third rule, third traffic, 26.98.251.12, interface G2, direction outbound. So we go ahead and we look at our interfaces. That is, in fact, interface G2. The direction is outbound. All of our access lists are inbound. So that means we don't have, so we do have a G2 in. So we do have a G2 in rule with an implicit deny out at the very end, but we do not have a G2 out rule. Since we have no G2 out rule, then there is no rules. There's no access list for it. Therefore, there is no implicit deny. No implicit deny. Traffic is allowed. Because we don't have a rule for it. All right. Next set of traffic, 192.168.242.1 on interface G2. It is inbound. We look at our interface G2. That's correct. Inbound. That's correct. So we start with our rules again from the top down. 192.168.242.1. We look at our first rule. 192.168.242.1. That matches. Therefore, we are being denied. There we go. All right. So the very first rule went and denied that, which might suggest that the more you expect something to be denied, you might actually want it to be the very first item on the list. All right. So that traffic, let's see. So this guy has been denied. This guy has been denied. Let's look at our very last source of traffic, 192.168.242.2. All right. Let's see, G2, interface G2, that is correct. It is inbound, that is correct. So this access list will apply to it. We start off 242.1, that is not our source. So that rule is skipped. We then go down to the second rule, 242.0/24. That fits in the /24 network. Therefore, this traffic is permitted. All right. So out of the 5 sets of traffic, 5 traffic sources there, we actually denied 2 of them due to these. All right, so that is the very introduction to access lists, how access lists work. There is more to learn about access lists. There's always a whole lot more to learn about access lists. But I hope this gives you an introduction to what's going on in access lists, how to actually use them, and hopefully how to have a successful career using them. All right, keep learning, guys.